All right, let me find the notes. So we're going to do the next page. So you should have your notes open to write in with Cami. Let me get nope smaller and fit more on the same page. And we're going to be doing, this one. Yeah, just this top part. Okay, so just notes 27. It's really just notes 27 part 1. We're going to do molecular compounds tomorrow. So just this top part here. Okay. All right, so we went over a lot of the things you're going to need to know about how to name ions yesterday in ion nomenclature. That was our first set of notes. Just now we're putting them together. So if you remember from yesterday, our first rule was that if a metal is in the first 2 columns in the periodic table, so let's draw one of my little periodic tables. There we go. So if it's in one of these 2 columns right here, then it always makes a +1 or +2 if you're in the first column +1, second column +2. So for metals in those columns, I don't need to change their name at all. They don't need Roman numerals attached to them to tell me their charge because I already know their charge. It's a +1 or a +2, and it always is. So they're not required to have that Roman numeral in their name. Whereas a metal in this section, so in this middle section and kind of a little over here as well, and the ones down below, all of those metals require Roman numerals. So I'm going to draw a little Roman numeral example up there. That's number 2 and a 5. Just to kind of remind you in this set of notes, anything found in that section needs a Roman numeral after their name to tell you their charge. And then lastly, actually, not even before it, if it is a negative ion, so remember we have -3, -2, -1 in these columns here. So if it's found in those negative columns, they're all nonmetals, then they have to change their name, the ending, to IDE. So whatever their name is, chlorine, sulfur, oxygen, they become oxide, sulfide, chloride. They all change their ending to "ide" for negative ions. Those are just the rules for naming, and now we're going to put those things together. So for writing formulas, they've already given you the names. You just have to give me the formulas back. So like their symbols and how many of them are there. And it's pretty simple, okay? So again, let me remind you, these are all ionic up here. Wow, this is like insanely not calibrated up here. Why? It seemed fine. What in the world? I was writing perfectly fine, except for in that one spot. It was like not even kind of on the right spot. Okay, sorry, hopefully that's better. So these are all writing formulas for ionic up here. There we go, that's more right. And so it has a metal with a non-metal, or it has a positive with a negative charge. Now, down below, we're going to learn tomorrow is how do I name non-metal bonds, which is molecular covalent bonds. And they are named different. They have different naming rules. So all the rules we're going to talk about today are just for ionic compounds, just for a metal with a non-metal, a positive with a negative, okay? You will not use these rules tomorrow in the molecular, except for like the mixed problems. So how we do this? Basically, the trick is I could always just write their symbols first. So calcium on the periodic table is Ca, and oxygen, oxide, because it became oxide when it was negative, so oxygen became oxide, so I know it's oxygen, is O. So CaNO. Now, you've seen throughout the year little numbers, like we have this one, H2O. Well, how did that 2 get there? How do I know that I have to have 2 hydrogens to that 1 oxygen for it to balance? Okay, so how did I know it got there? You did the puzzle pieces yesterday, so like putting them together and seeing why some things need more of one element than another to balance their charges. But how do I know it right now? Like I don't have the puzzle pieces. So the quick way is you find where the element is on the periodic table, write their charge on top of it. You're not going to leave it there It's not going to be a part of your end result, but it's how I get my answer. So calcium is in this second column here. Okay, so if it's in the second column, then it has a +2 charge. Oxygen is in this column here, and it makes a -2 charge. That's just where they're at in the periodic table that you should have had labeled already for many, many weeks now. Now, with those charges above it, you literally just crisscross the numbers down to figure out how many of them they're supposed to be. So it'd be like this, okay? Except for any time you can reduce. If you can reduce it, you are supposed to reduce it. Meaning, if I have 2 and 2, well, if I divide them by each other, like 2 divided by 2 is 1. So they both can divide by 2, and they both would equal 1 and 1. So in reality, this compound, when it forms, if I reduce it, is just CaO. Like that actually was done. If we just wrote their symbols down, 1 calcium and 1 oxygen balances out. Now, another way to think about it, before I move on, is you write those charges, +2, -2, and you think about, I want it to equal 0. That's my goal, a neutral, balanced compound. So +2 -2 equals 0. Well, that's true. +2 -2 does equal 0. So this is already neutral. I just needed 1 and 1 of them to balance. So then you would know that way too without crisscrossing. All right, let's try another one. Aluminum is in the -3 column on the periodic table. Nitride, so think about the name, ends in "ide." It's nitrogen. Okay, so nitrogen is in the -3 column. I think this is +3. Aluminum's +3, sorry. Nitride is a -3 column. Okay, now the same thing happened before. I could crisscross and I would get A, L, N, and it'd be 3, 3, and then I'd realize I could reduce them both to 1 and 1. Or again, I could just think about it. +3 -3 already is 0. This is already neutral. We're just adding 1 aluminum with the 1 nitride, the +3 charge balances out the -3 charge, and they would literally just be that, ALN. That's the compound. So I guess I'll write them closer together so they look more right. There we go. So that's the compound. Okay, let's try sodium sulfide. So sodium is in the first column. It's Na. And it has a +1 charge. Sulfide is in the same column oxygen's in. It has, its symbol is S, and it has a -2 charge. Okay, so when I think about this one, +1 -2, does that equal 0? No, it doesn't. It doesn't equal 0 right now. So this is the first time this has happened so far. If it doesn't balance 1 on 1, that +1 coming from sodium does not balance the -2 coming from sulfide, then that's when that crisscross method happens. So I criss the 2 down, and I criss the 1 down. Now, what that is saying is that I need 2 sodiums. I need 2 +1s. I only need 1, because I crisscross the 1 to sulfide. I only need 1, -1. So +1 +1 is 2. 2 -2 is 0. So now I have fixed it. And I end up needing 2 sodiums for every 1 sulfur. And I don't have to write the 1. So you could, but you don't need it. Not required to write the 1s. So Na2S is how that compound would work out. You would need 2 sodiums for every 1 sulfur to balance that compound. Okay. Next one, iron is Fe on the periodic table, and chlorine is Cl. Just a little forewarning, usually when we do this test, it is a written test for the most part. I'm not sure if we'll keep it that way. I know we have a lot of virtual kids. We might make it all digital this year, but a lot of times I have you write some out. But you can always get partial credit, even for in your worksheets. If you get any of these correct, like you get the symbols correct, you get some of the numbers correct, I do usually get partial credit. So you always do as much as you can. Don't leave things blank. Okay, so iron is Fe, chlorine, which becomes chloride, is Cl. Now I write their charges above it. So this is telling me, remember yesterday, the Roman numerals that we wrote is telling you the charge. So this iron is a +3. Chlorine is in the -1 column on the periodic table, so it's a -1. Now again, I ask myself that question, +3 -1, does that equal 0? No, they do not balance 1 to 1. So I'm going to do my crisscross method. So the 1 from chlorine is going to cross over to iron, the 3 from iron is going to cross over to chlorine. So I'm going to need 1 iron for every 3 chlorines. Now you want to think about that mathematically. Well, every every chlorine is a -1. So I need 3 -1 now, and I only need 1 iron, which is +3. So +3 -1 -1 -1 is 0. So now they're balanced. I needed 3 chlorines to balance that compound. Okay, next one. So again, the Roman numerals tells you its charge. That is the Roman numeral for 4. So this lead is +4. The symbols for lead is Pb. And it used to be called plumbic in Latin. Oxygen, or that became oxide, is in the -2 column. So again, does +4 - 2 = 0? No. If it doesn't, then I got to do my crisscross. I'm going to cross the 2 down, cross the 4 down, and it becomes lead 2, oxygen 4. I need 2 leads for every 4 oxygens. But again, if I can reduce, I must reduce. So every time you get even numbers, basically, if you see even numbers and you have 2 even numbers, then you can reduce them. So if I divide both those numbers by 2, then I get just 1 lead, and I'll get 2 chlorines. 2 oxygens. Whoops, wrote the wrong one. Try that again. PbCl. Now I only need 1 of the PBs and I need 2 Cl. So I reduced it. Okay. Next one, nickel is a +2 because it tells me in the Roman numerals it has a 2 charge. Phosphide was phosphorus. Phosphorus is in the -3 column. Ask myself, do those balance on their own? +2 - 3. No, they don't equal 0. So I crisscross to get my numbers. So nickel gets the 3 crossed down, and phosphorus gets the 2 crossed down. I can't reduce that because one of them is an odd number, one is an even number. So that's it. Nickel 3, phosphorus 2. So Ni3P2. Okay, now, if you want to take a second and work on your worksheet and come back to finish the notes in a second, you could. The top part of your worksheet is just practicing those kind of ionic compounds. Just regular metal, regular non-metal, write their charges, crisscross them. If you have to reduce, reduce. After that, though, you do have polyatomics. So remember yesterday we learned that if something ends in ate or ite, then it's a polyatomic ion, and you have to go look it up. It's not something you can find on a periodic table. It's not something I expect you to memorize. It's something that I expect you to go look up on the first page. As soon as you notice that it ends in ate or ite, you go look it up. Now, there were a couple exceptions to the rule that I pointed out yesterday, and that was ammonium, cyanide, and hydroxide. Those are the 3 polyatomic ions that you also have to look up to know what they are and to know their charges on your polyatomic ion sheet from yesterday, just at the top of your notes in this packet, that don't end in ate or ite. So cyanide, hydroxide, and ammonium don't end in ate or ite, so it might throw you off, but you're supposed to know those, okay? So let's go find sulfate. Let me just show you what I mean, and I'll come back to this spot. So I'm going to find sulfate up here. Remember, on our first page, we had our group of polyatomic ions. You had your quiz this week on Friday over group 1 and over group 2. Okay, so I'm going to look for sulfate. I know I have writing everywhere. It's right here. Okay, so that's sulfate right there. So sulfate, literally what sulfate is, I don't do anything to it or change it, it is SO4, and it has a -2 charge. I'm going to need to know that. SO4, and it has a -2 charge. For the rest of these, I'm just going to trust that you know I'm going up and looking what they're called. There we go. There we go. Okay. So sulfate is SO4, and remember I write their charges above and over here. It has a -2 charge. So I'm going to need to know if I need more or less of them. Lithium is just a regular metal. It's in the first column, so it has a +1 charge. So nothing changed there. Just when I notice something ends in H or I, I'm going to have to go look it up. I have to go look at the polyatomic ion. And lithium is Li. Okay, so then same thing. Ask myself, does +1 - 2 = 0? No, it doesn't equal 0. It doesn't balance. So I'm going to do my crisscross method. So the 2 comes down to lithium, and the 1 comes down to sulfate. I don't have to write ones, so there you go. Li2, SO4. That's that compound, lithium sulfate. Now, chromium. Chromium has a +3 charge, because it tells me so in the Roman numerals. Nitrate, okay, I've noticed it's a polyatomic ion. It ends in ate or ite. Nitrate on my polyatomic ion list is in O3. and it has a -1 charge. That's just what nitrate is. It's NO3 with a -1 charge. Again, ask myself, chromium and Cr, does that equal 0? +3, -1? Nope, doesn't balance out. So now I got to crisscross. Now you haven't seen this one before, so I want you to take a look at how weird this looks. When I put a 3 like that, that kind of looks like I'm saying I need 33 oxygens. I don't want 33 oxygens. I want 3 nitrates. I need 3 of the nitrates. So what I do to show that is I put nitrate in parentheses. And now that 3 is covering everything inside the parentheses. I need 1 chromium and I need 3 groups of nitrates in that compound. And there you go. So anytime you have to cross down a number on a polyatomic ion, it needs to be in parentheses. Okay, copper has a +2 charge. The Roman numerals tell me so. Cyanide was one of our exceptions, ammonium cyanide hydroxide. It's also a polyatomic ion. I went and looked it up. Cyanide is Cn, and it has a -1 charge. Copper is Cu. There we go. Does +2 - 1 equal 0? Nope, it doesn't balance. So I'm going to have to cross the 2 down to cyanide. Remember, I don't want 2 nitrogens. I want 2 whole cyanides. And then the 1 crosses down to copper. I don't have to write the 1. There you go. Cu, parentheses, Cn, close parentheses, 2. And lastly, we have zinc. Zinc was our exception to the rule. It's in this section up here. It's in the middle that normally needs Roman numerals. But this one, we've labeled it. We should have labeled it several times now in your periodic table. Silver is always a +1, and zinc and cadmium are always a +2. They're not like these other ones that are green in the middle. They actually do always have the same charge. So zinc, as mine says, is labeled a +2. Zinc is always +2. And then I notice this is HRite, so I go look up what phosphate is. Phosphate is PO4 and it has a -3 charge. It has a high charge for most of our polyatomics. And zinc is Zn. There we go. +2 - 3 does not balance to 0. So I cross down the 3 from phosphate to the zinc. I cross down the 2 to the phosphate. I don't want 42 oxygens. I want 2 phosphates. And there you go. That is how you name, not how you name. That is how you write chemical formulas from a name in ionic compounds. So things that have a metal or a non-metal and are bonded together. Okay, that's it.